Welcome back to another SolidWorks tutorial. In today's video, I'll introduce you to one of the 3D features in SolidWorks. We'll explore what it does, how it works, and how it can help improve your design workflow. I'll also walk you through a practical example so you can see how to use it in your own projects. Let's get started. Now, let's create a new part drawing from scratch. To begin, I'll select the top plane and create a new sketch. Next, I'll draw a circle and position it at the center. Next, I'll extrude this sketch to a thickness of 50 millimeters. To continue, I'll create a new sketch on the top face of the extruded feature and perform another extrude with a 50 millimeter thickness. I'll repeat the same step as before, but this time with a 25 millimeter thickness. On the left side of the window, you'll find the SolidWorks feature design tree, which shows the full history of how the part was created and makes it easy to modify any feature or sketch. Let me change the dimension from 160 millimeters to 120 millimeters. The feature design tree is useful because it lets us easily review the design history, especially in team projects where one designer needs to continue the work of another. Now I will apply a fillet radius to the model to smooth the edges. Let me create another circular sketch on the top with a 20 millimeter diameter and extrude it through all. I will use the front plane to create a section view so we can see the internal structure of the part. Let's add another sketch on the bottom surface and perform an extruded cut. With a 30 millimeters diameter, I will extrude cut this and select the up to surface option. Next, I'll select the first layer as the reference surface. I will add another sketch, this time using the external surface as my sketch plane. I will enter a 20 millimeters diameter and use the same approach as the previous step, performing an extruded cut with the up to surface option. Now I will apply an internal radius to smooth the inner edges of the part. Next, I'll add a chamfer to the outer edges of the part. Let's save the drawing and name it Sample B1. What if I told you that this entire part could actually be created using just one sketch and a single feature? Let's create a new part drawing. I will select the front plane to start the sketch. Next, I'll draw a center line to use as a reference for the sketch. I'll continue the sketch by creating a profile that resembles the layers of a round cake. Please note that I'll apply the same dimensions used in the previous part drawing, so I won't go through each dimension individually. As you can see on the screen, when I dimension the outside line to the center line and then move my cursor to the opposite side, SolidWorks automatically displays the dimension as a diameter, creating a symmetrical dimension. Because the sketch is underdefined, it can still be moved by dragging it, indicating that additional dimensions or relations are needed. I'll continue adding dimensions until the sketch is fully defined. Let me remove the internal vertical line and replace it with a profile similar to the one used in the previous part. Again, I'll add the necessary dimensions and sketch relations to fully define the sketch. Right now, I'm applying the same dimensions as the previous design, including diameter and height, to keep everything consistent. I will apply a 2 mm internal radius. I will also add a 5 mm fillet to the external edges. Then I will apply a 1 mm by 45 degrees chamfer to the edges. Our sketch is now fully defined. Let me introduce the feature called Revolved Boss / Base. In SolidWorks, the Revolved Boss / Base creates a 3D model by rotating a 2D sketch around an axis, allowing you to form symmetrical shapes such as shafts, bottles, and wheels. Let me change the top layer height of the second sample to 25 millimeters. If I create a section view of the part, you'll see that it is identical to the previous sample, but with fewer features. Finally, I will save this part as sample B2. So why am I showing this saving step? It's to highlight that sample B1 has a larger file size than sample B2. This is due to the number of features used to create sample B1. This difference can have an impact when working on assembly designs with a large number of parts, as larger files can slow down the computer system. Thank you for watching this tutorial. I hope you found it helpful. Don't forget to like, subscribe, and leave a comment. See you in the next tutorial.